Welcome back to our digital electronics series. In this episode, we are diving into a powerful tool for simplifying Boolean expressions, Karnaugh maps or K-maps. Whether you are designing complex circuits or just getting started with logic design, K-maps offer a visual and intuitive way to minimize logic functions and create efficient circuits. Let's explore how they work. Karnaugh maps, named after Maurice Karnaugh, are a method for simplifying Boolean algebra expressions. They provide a visual way to identify and eliminate redundant logic, making it easier to design efficient digital circuits. A K-map is essentially a grid that represents the truth table of a Boolean function. Each cell in the map corresponds to a possible combination of input variables, and the values in the cells indicate whether the output is true or false for those inputs. Let's walk through how to fill out a Karnaugh map. Suppose we have a Boolean function with three variables, a, b, and c. The first step is to list all possible combinations of these variables and their corresponding output values. Next, we transfer these output values to the corresponding cells in the Karnaugh map. The map is arranged so that each adjacent cell differs by only one variable. This is known as gray code order. Once the map is filled in, the next step is to group adjacent cells that contain the value 1. These groups can be of size 1, 2, 4, or 8, and they must be rectangular in shape. The goal is to create the largest possible groups, as larger groups represent more simplified expressions. For example, in this 3-variable map, we can group these 4 cells together. This group represents a simplified expression where certain variables are eliminated. Now, let's derive the simplified Boolean expression from our groups. Each group corresponds to a product term in the Boolean expression. The variables that remain constant within the group form the product term, while variables that change are eliminated. For our example, this group corresponds to the expression h. By combining all the groups, we obtain the minimized Boolean expression for the original function. Karnaugh maps are invaluable in digital circuit design. They help reduce the complexity of combinational circuits, leading to fewer gates, less power consumption, and improved performance. Whether you are designing adders, multiplexes, or any other digital component, K-maps can simplify your work and optimize your designs. For example, here's a circuit before and after applying K-map simplifications. Notice how the simplified circuit uses fewer gates, making it more efficient. And that's how Karnaugh maps help us simplify Boolean expressions and create more efficient digital circuits. Understanding and using K-maps is a fundamental skill in digital electronics that will save you time and resources. Thanks for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the bell icon to stay updated with our latest content. See you next time.